Hi class. In this lecture, I want to follow up on the previous lecture. We were talking about sets by defining what we call subsets. And subsets are exactly what you think they would be. They're sets that are a smaller part of a larger set or certain smaller elements of a larger set. Okay, so the objectives in this lecture are threefold. We want to recognize subsets and use this notation here. I'll define that in a second. We want to recognize proper subsets and use this notation. Notice the subtle difference here. And then third, we want to determine the number of subsets for any given set. Okay, the total number of possible subsets there could be. All right, so let's start with the definition. So the definition of a subset of a set. A set A is a subset of set B expressed as A is a subset of B. So this notation means subset if every element in A is also an element in B. So this notation A and then the subset notation with the line through it means that A is not a subset of B, and set A is not a subset of B if there is at least one element of set A that is not in set B. Also, every set is a subset of itself, meaning like if you have the set A is the numbers 1 and 2, and the subset of that set would also be the set 1 and 2. Okay, so that counts. All right, so let's talk about this subset. Okay, so let's write a subset or is not a subset in blank to form a true statement. So I have A, which is the numbers 1, 3, 5, and 7, and B is the numbers 1, 3, 5, 7, 9, and 11. You notice how all the elements in set A exist in set B? So here it looks like set A is a subset of set B, so we would put this notation here. So A is a subset of B. Now you have to be careful here. Set A here, there's a little typo. This should be B here. Okay, sorry about that. A is equal to X such that X is a letter in the word proof. And B, sorry about that typo there, is equal to Y such that Y is a letter in the set roof. All right, well, this is a little weird. Is every element in set A also in this second set here? Well, no, we have this extra P. So A is not a subset of B, so we would write it like this because A has more elements in it than B. It would be noted that B is a subset of A, though, however, okay? So just be careful of that. Let's talk about proper subsets now. Set A is a proper subset of B, expressed as A. So when you see this without the line under it, it's just saying A is a proper subset of B. If set A is a subset of set B, and they are not equal to each other. Okay, meaning they don't have the same number of elements in it. All right, so let's write as a subset or a proper subset or both in the blank to form a true statement. Okay, so set A. X such that X is a person and X lives in San Francisco. Okay, so there are certain people who live in San Francisco, right? B, X such that X is a person and X lives in California. Okay, well, think about this. Do all the people who live in San Francisco also live in California? Yes, so they're part of it. But there are people who live in California that do not live in San Francisco. Yes, they're a subset of each other. Now, it's a proper subset. Are there less people who live in San Francisco than live in all of California? Absolutely. Absolutely. So the solution here is that both. Okay, it's both a subset and it's a proper subset. Now let's look here. Set A is equal to 2, 4, 6, 8. Set B is equal to 2, 8, 4, 6. Now these sets are actually the same thing. They're equal sets, right? They have the same elements. So in this case, we would just say it's a subset, right? So set A is a subset of set B. It's not a proper subset because these two sets are actually equal. So subtle difference there. All right, let's talk about empty sets and subsets. The empty set is a subset. So for any set B, the null set or empty set is a subset of B. And actually for any set B, and as long as B is not the empty set itself, well, then the empty set is a proper subset of B, always the case. All right, so when it says list all the subspace of a certain set, you have to include the null set or the empty set. Okay, so let's talk about the number of subsets for a given set. Okay, so if you have a set The empty set, the number of elements in it are 0. List all the distinct subsets. Well, that's just the empty set itself, so there's one subset. You have the letter A, the set that just contains A. The number of elements in that is 1. The list of distinct subsets are A itself and the empty set, so there's 2. If you have the set AB, there are 2 elements in it, and the subsets are the set itself, A and B, the set of just A, the set of just B, and don't forget it's always the empty set. So in that case, there are 4 elements. If you have the set A, B, and C that has 3 elements, well, these are all the subsets. It's the set ABC, it's the set AB, the set AC, the set BC, the sets A, the set B, the set C, and the empty set, of which there are 8. So as we increase the number of elements in the set by 1, the number of subsets doubles, actually. So if you notice here, you go 1 to 2 to 4 to 8. So for example, if there were a number of elements in a set were 4, there would actually be 16 subsets. All right. So the number of subsets of n is equal to 2n. The number of proper subsets then, because remember, proper subsets don't include the set themselves, all right, with n elements is 2 to the n minus 1. So for any set, any number of a set with any number of elements in it, okay, so if it has 5 elements in it, then the number of possible subsets is 2 to the 5th power. Then the number of proper subsets, okay, would be 2 to the 5th power minus 1. All right, so let's find the number of proper subsets for this. Well, here, again, the number of just proper subsets. Okay, so it's 2 to the n minus 1. Here we have A, B, C, D, and E. So there are 5 elements. So there are 2 to the 5th equal 32 subsets, and 2 to the 5th minus 1, which is 31 proper subsets. Here, x such that x is a natural number and is between 9 and 15 inclusive. Okay, so in roster form, we see there are 7 elements, 9, 10, 11, 12, 13, 14, and 15. So there are 2 to the 7th, which is 128 subsets, and 2 to the 7th minus 1, so there would be 127 proper subsets. All right, that's just a quick introduction to subsets.